Let's go on to number 4. Okay, number 4, the base is between 0 and 1, so it's going to be a decay. Okay, and I'm going to make another table of values. And since this is a simple graph, it's like a parent graph, it's one of the simplest ones, I'm going to use -2, -1, 0, 1, and 2 again. Now the next graph we do after this is going to have some transformations to it, and we'll have to think of different values for the x to plug in. But for these, those simplest ones, we can just use those 5. Okay, so when I substitute -2 in for the x, that negative flips the fraction over. So it's actually y equals 3 squared. So your y value is going to be 9. When x is -1, y is going to be 3. What is y going to equal when x is 0? 1. That's right. Okay, when x is 1, y is going to be 1/3, and when x is 2, y is going to be 1/9. So let's graph those points. Bless you. Okay, -2, 9. That value is like way up there, so I'm just going to put a little dot there to represent it because I didn't go up that far. And -1, 3, 0, 1, 1 and 1/3, and 2 and 1/9. Okay, and there's your graph. So just like the growth function, the graph is going to approach the x-axis, but it's not going to cross it. Y is not going to equal 0. There's no value for x that can make y equal to 0. But since it is a decay, that means that as the x values increase, the y values decrease. Okay, so you have an opposite effect going on. With the growth function, they both went up or they both went down. Y function, x goes up, y goes down, and vice versa. Okay, so your domain here, there's no restriction on the x, so it's all real numbers for the domain. And on the range, all the values are above the x-axis, so all values of y so that y is greater than 0. Okay, any questions? All right, so let's look at number 5. Let's do number 5 together, and then I'm going to let you guys do number 3 on your own. So number 5 is a little more complicated because it has a value that's multiplying the base. It has an exponent that you're going to be adding something to, and then the -3 out there on the end. So right now, just looking at this equation, I can tell that -3 is going to be the horizontal asymptote, right? And the graph is going to approach -3, but it's never going to cross that. Okay, so you can kind of get in mind what it should be looking like just by looking at the equation. The base is between 0 and 1, so it's going to be a decay. It's going to start like this one. It's going to start up high and then come down low. Okay, so let's make a table of values. Now, on this one, since I have some transformations that are taking place, instead of using those same 5 values that I did before, I want to look at my exponent and think about what should I put in for x that's going to make that 0. And that's going to be a -2. And I'm putting it in the middle because I probably am going to choose some values for x that are smaller than that and probably a couple that are larger also. All right, so let's put in a -2. That means I have y equals 2 times 1/4 to the 0 power minus 3. Anything to the 0 power is 1. 2 times 1 is 2, minus 3, y is going to be negative 1. Okay. So I'm just going to put a negative 3 in there for the x. Let's see what it does. 2 times 1/4 to the, if x is negative 3 plus 2, that means my exponent is going to be negative 1. Okay, so 1/4 to the negative 1 power is what? 4. 2 times 4 is 8, minus 3, it's going to be 5. Okay, so let's put in negative 1. Y equals 2 times, when I put a negative 1 in here for the x, that means my exponent is going to be a positive 1. 1/4 to the first power minus 3. So 2 times 1/4 is a half. 1/2 minus 3 is negative 2.5, right? So that's pretty close to negative 3 already right there. So that means if I put in, let's put a 0 in for the x so we can see where the y-intercept is, just because. Okay, when I put a 0 in, then y is 2 times 1/4 squared minus 3. So when I square 1/4, that's 1 over 16 times 2. It's 1 over 8 minus 3. It's going to be negative 2 7/8. So that's really close to negative 3. Okay, so I'm going to graph this now. I think that's enough points. Negative 3 and 5. Negative 2 and negative 1. Negative 1. Negative 2.5. 0 and negative 2 7/8. Okay, so there's my graph. So your domain, again, it's going to be all real numbers. There's no restriction on your x. But for the range, y has to be greater than negative 3. It's not going to be less than negative 3 ever. Okay, so here's your graph for number 3. The negative 1/2 out in front has flipped it over. And you can tell by the base that this is a growth. Without being flipped over, it would look like this, right? So your domain here is going to be all real numbers, and the range is going to be all values of y so that y is less than 0. Question?